Here are the answers for the section 5-3 homework. On page 166, we're given some expressions that have some exponents and some negative exponents. We're asked to simplify them. So in number 1, the 15 has a positive 1 exponent. Let's leave 15 in the top, and then the 27, which has a negative 2 exponent, move it into the bottom and give it a positive 2 exponent. Now, one way to get the final answer would be to type this in a calculator, push enter, and have the calculator reduce it for us. But we don't need to do that because we can reduce the 15 over 27 ourselves. We have 15 on top, and on the bottom, a pair of 27s. 15 and 27 both divide by 3. So 15 divided by 3 leaves 5, and 27 divided by 3 leaves 9. So on top we have 5, and on the bottom we have 9 times 27. That makes 243. Number 3, let's reduce the 2 and the 6. They both divide by 2. 2 divided by 2 leaves 1, and 6 divided by 2 leaves a 3. Then for the a's and the b's, we'll use the rule about subtracting the exponents. So we're left with negative 1 on top, and b, because b to the second subtract b to the first is a b in the top. Down in the bottom we have 3, and we have a, because when you subtract the exponents on the a, the extra 1 is down in the bottom. Number 5, the part that has the negative exponent can be moved into the bottom of a fraction. Now we can divide using the distributive property. 2x divided by 2 makes 1x, and 6 divided by 2 makes positive 3. Number 7, the part that has the negative exponent can be moved down into the bottom of the fraction. And we're left with 4t over 4t minus 12. Observe that all of the terms can be divided by 4 to reduce them. So 4t divided by 4 is t, 4t divided by 4 is t, and 12 divided by 4 is a 3. Number 9, the top and bottom are both subtractions, but this one on the bottom is just the opposite order of what's on top. And notice that it is not in standard form. It doesn't have the variable first and then the constant. Let's factor that as negative times t minus 1. We did that once in a while in the chapter about factoring. Now we have a common factor, top and bottom, which reduce. These cancel away, leaving a 1. So we get negative 1 as the answer. A faster way to get the answer is to recognize that the top and bottom are inverses of each other. When you divide inverses, you'll get negative 1. Number 11, we have common factors. Let's use the rule about subtracting exponents. When you subtract exponents, where will there be some left over? In the top or in the bottom? They're going to be left over in the bottom. 5 subtract 3 is an exponent of 2. Number 15, the numerator can factor. We can factor an a squared y out of both terms, leaving a minus 1. Down in the denominator, let's just copy what we had. Now we have some common factors, top and bottom, which will cancel away and create 1s. A squared y divided by a squared y reduces to just 1. And the a minus 1 in the top will cancel 1 of the a minus 1s in the bottom, leaving 1 of them left over. One way to show that is to slash this away and slash the exponent away, replacing it with a 1. We're left with 1 on top and a minus 1 on the bottom. Number 21, let's factor the trinomial. It factors as x plus 6 times x minus 1. And then in the bottom, we'll just copy what was there. Now cancel any like factors. X minus 1 divided by x minus 1 just leaves a 1. X plus 6 cancels one of these away, leaving 1 remaining. So we have a 1 on top and an x plus 6 on the bottom. Number 27, we have that situation from earlier where we have division and we have inverses. A minus B is the opposite thing of B minus A. Do you remember what they reduce to? This divided by this makes -1. This divided by this makes a -1. This divided by this makes a -1. So we have negative times negative times negative times negative. That's an even amount of negatives. The final answer is +1. For the review, we're kind of doing the same thing. Let's work with these expressions. The one that has a negative exponent can be put down in the bottom. We're also asked, what are the undefined values? What are the numbers you cannot use for r? We do not want the denominator to turn out to be 0. So if you add 1 to both sides, r cannot equal 1. Number 19, the part with the negative exponent, move it down into the bottom. Then think about if there's any number that u cannot equal. We do not want the denominator to equal 0, but there's no way that it could be, because whatever u is, as soon as you square it, you're going to get a positive result. And a positive number plus 36 is never going to turn out to be 0. So there are no restricted values for u. On page 161, the same sort of thing. Let's work with our expressions, and if we have negative exponents, use the idea about reciprocal. So the reciprocal of 1/3 is a 3, and it goes to the +3 power. And this makes 27. For number 4, let's do the work in the parentheses first. 5 minus 2 makes 3, and that's going to the -2 power. A negative exponent means a reciprocal, and now it goes to the +2 power. 1 squared is 1, and 3 squared is 9. Number 8, the negative exponent means a reciprocal, so turn that fraction upside down and give it a positive exponent. 2 squared is 4, and 3 squared is 9. Number 12, 75 to the 0 power. This part right here just turns out to be 1. So we have 1 times 3 to the -3, which is just 3 to the -3, and that's being raised to the -2. Use the rule about multiplying the exponents. The answer is 3 to the 6th power. If you'd like to have that as a number, you could type it in your calculator and push enter. Number 18, let's use the rule about dividing by subtracting the exponents. Start with the letter A. -5 subtract 1 is a -6. Now do the letter B. 3 subtract -4 is a 7. The b to the 7th will stay in the top, but the letter A had a negative exponent. Move it into the bottom and give it a positive exponent.